Hello everyone and welcome back. I'm Ostrus, and today we're going to go over Z-Image-Turbo. We're going to train it on AI Toolkit. I'm excited. Let's get started. Z-Image-Turbo dropped a few days ago. They're also going to release Z-Image-Base, which is the model you really need to train on, and they're going to release Z-Image-Edit. Early on, right when they released Z-Image-Turbo, this one, it's an 8-step distilled model. It can do less than that, actually. They say here that they will be releasing Z-Image-Base, Z-Image-Edit. Everyone thought this was going to come day 1 or day 2. I got super anxious because on Flux Schnell, when this came out, this is also a turbo model. I built a training adapter for this early on so that you could train this in AI Toolkit directly without breaking down the distillation. This was something I experimented with for a very long time. It took a long time to perfect it and get it just right. And so when Z-Image-Turbo came out and they hadn't released the other models yet, I wanted to train this because this model is amazing. It does amazing realism, and it's only 6 billion parameters. So it's small compared to like Flux is 12 billion or Flux 2 is 32 billion. This one's only 6. It's fast. It can do it in 8 steps. So when you're generating this, it's super fast, super lightweight. They didn't release the base yet. And early on, everyone thought it was going to be released in a day or two. And then there was some confusion on their GitHub repo where they were answering a different question, and people thought that meant that the model was going to be released by the weekend. But it turns out what they were talking about is the prompt upsampler. They said it would be a little bit on the image base. Luckily, I was already working on an adapter so we could train this thing. But before we get into all that, I want to give a shout out to Alibaba. So this is Tongyi, I can't pronounce that, but it's a subsidiary of Alibaba. It's a group within Alibaba. And if you don't know, a lot of the big open models that have come out, like Apache 2.0, completely open models with permissible licenses, have come out of this. You can tell all these. So you look at Juan, Quinn, they all have, you can tell they have that same logo. That's the Alibaba logo. So it's all from the same company, but they're just labs within that company. So, we owe so much of the current open source image generation and also text generation and video generation to Alibaba. They're just doing amazing things in the open space right now, and I think we really need to appreciate what all they've done for us. So let's get back into this Z-Image-Turbo. So you can't train this directly. It's a distilled model. If you train it, it'll break down. So I came up with a while back a way to do a training adapter. And here's my Z-Image-Turbo training adapter. You can go here. I'll post a link in the description. But basically how this works, when you train on Z-Image-Turbo, so this is 8-step, no CFG. So it doesn't have to do a dual pass. It's a single pass. This only takes 8 steps of a single pass. Normally you have to use CFG, so there's 2 passes, so it takes twice as long. This one, since it's a distilled model, you do 8 steps and you get these images. This is the base. And I was training in my musician character. I've mentioned them a few times. I've posted pictures a few times. We've done tutorials a few times. But this is basically what they look like. Now, when you train this without the adapter, this actually starts to break down. You can see like these weird artifacts happening. This is after 500 steps. And you see all this, like it's breaking down. So the model, general diffusion models, they want classifier-free guidance and about 20 to 50 steps to make a good image. That's how every model that's come out, that's what you have to do. And so when you're training it, it's breaking down to try to do that because we're doing traditional training here. When they distill it, they actually do student-teacher so that they'll essentially shorten the amount of steps it takes. This is a short definition of it, but that's basically what's going on in the high level. There's critics now and a bunch of other things. We've gone from LCM. There's a lot of different ways to do this, and they've done it a different way as well. But that's the basic gist. You're squishing down the steps into where it can do it in very few steps, even 1 step if possible. But when you start training on that, the model wants to restore back to its original state of being a 20 to 50 step model that requires CFG. And you can tell here, this is 8 steps, no CFG. And so after 500 steps of training it is learning my character, but it's also breaking down that distillation. There's a point like here, we probably, if we add a little CFG, it would be clearer, or if you do more steps, it'd be clearer. But as you continue to train this, it would just break down completely to where you would need 30, 40 steps, and you would need classifier-free guidance to make this look good at all. And so you don't want to do that with every single LoRA you train because you want the turbo. So that's where the adapter comes in. You can see it here working. You get nice, crisp, clean images without breaking down the distillation. So you can come here and read how it works. The basic idea is I generated a ton of images, a huge data set with Z-Image-Turbo. And then we just train a LoRA on that. And over time, it'll break down. So it's just breaking down the distillation, but it's not going to learn anything new. It's not learning our character. It's not learning any new information. This is all information that's inside the model. So when we train, what we can do is we actually take this adapter LoRA that now has all the distillation broken down, and we apply it to the model, and we train on top of that. So that way you're basically training on a model without distillation. So it's just going to learn your concept or your character. After that's done training, or when you're sampling, you remove the training adapter. So now you remove the de-distilled LoRA, and what's left is your new information on the distilled model. So you can basically train a LoRA on a turbo model without breaking down the turbo. It'll allow us to do things like inference and get great quality in very few steps while still teaching it whatever we're trying to teach it. Teaching it about our character, concept, etc. This is a de-distillation training adapter. This is how it's going to work. It's already built in the AI Toolkit. We're ready to go. We're ready to train. Let's get started. I'll show you how you can use this, and I'll talk about some of the caveats along the way. You can kind of see here what's the catch. The basics is you're not going to do a 5 million image fine tune using this adapter. It just slows down the de-distillation process. Over time, if you train for 20 million steps, you are going to break down that distillation. But for 5,000, 10,000, maybe even 20,000 steps, you're probably fine on training characters, styles, things like that. And that's what we're going to do today. Now, I'm currently in the process of moving. I would do this locally. I'm going to do it on RunPod today because I have a lot of stuff packed up. I actually didn't have time to record this video, but it's been highly requested. And since this is a new type of training and a new type of thing, I wanted to make sure I went over it and explained how this works and the caveats. That being said, I don't have my GPUs set up and ready to go, so I'm going to use RunPod. You can totally do this locally. It is a small model. 24 gigs of VRAM is fine. Less than that's fine. I think you could get by with 16 without doing any real offloading, like block offloading with RAM torch. I'm going to go ahead and pop over. I'm going to do a 5090 just for speed. I'll post a link of how to do this in RunPod if you want, but I'm going to blow through it real quick. All right, so we're up in AI Toolkit. Again, you can do this all locally. Just go to the repo. There's instructions on how to install it there. I mean, this will work. I'm doing it on a 5090 here just to demonstrate. Let's come over to datasets. So I already have a dataset prepped. This is an older one I've done. Children's drawings. Sounds good. We're going to add our images. Just going to drag these. Now I'm going to save you guys the time. I already captioned all these. And you can just drag captions in, the .text files. That works fine. Just drag it over. And you can tell all my captions are already here. These are just a bunch of children's drawings I found on the internet. Just real simple ones like sun and, people. Now, how I'm going to do this one, you can do a trigger word, and that does seem to help a lot when you're training. That's one way to do style. Another way to do style is to just caption it. So, like for instance, on this one, we just have a bear, a pig, a green balloon, an owl wearing suspenders, a donkey, and a blurry man with a red shirt standing on grass. A bunny man with a red shirt standing on grass. So I just describe what it is, if it's a picture or whatever. I'm not mentioning it's child drawing and, rough crayon sketch, crude drawing, anything like that. I'm just acting like this is the new normal. The new normal is when someone types in a picture of a woman, you get this. And when someone types in an owl, you get this. And a house looks like this. And so I'm teaching the model these normal things it knows. This is how you're going to render them now. Pretty simple. That's how I like to do style. Some people like trigger words. Trigger words are good. They do seem to help sometimes, but I really like it where it's just, you apply the LoRA and this is just how it works. So that's how I'm doing it today. Let's pop over to new job. I'm going to go over some settings real quick. We'll just do Z-Image-Turbo, children's drawings. I'm going to skip trigger word. On the architecture, you can scroll here, or you can just type in, Z. There's only one model with a Z in it. I didn't realize that. That's pretty impressive. Now on this, because this is the Z-Image-Turbo, we have a training adapter. If this is Z-Image base, I'll have that in here when they release it, and you won't need the training adapter. But the training adapter is already built in. You don't have to go download it. This just pulls it straight from the repo, and then it tells it which file name to pull. It's currently V1. I am working on a V2, just training it a lot longer, so it'll be a little better. When that comes out, this will automatically update if you're doing a new one. If you're cloning an existing one, you'll need to just upgrade this to V2 when that comes out. So you could do that, but it's not currently available. So we have our training adapter. All this is going to automatically work in AI Toolkit. It'll merge it in starting out, and then it'll merge it out when you're inferencing. So we can still do 8 steps. I'm going to leave all this the same, 3,000 steps. On the learning rate, this is 1e-4. There have been some people test it with 2e-4, and it exploded the model. So I would not go any higher than this. This seems to be kind of the sweet spot, but all the defaults are good. Today, I actually want to use differential guidance. This is what I use to actually train the turbo adapter. You can read about it here. It's in the advanced section. You can see the basic idea of differential guidance is normally you're moving your target, or you're moving your current knowledge closer and closer to your target with your learning rate. So it's going boom, and it'll jump a little closer, a little closer, a little closer, but you never actually get there. So it's just a little bit at a time, and then you just get, the differential becomes less and less, so you just get smaller and smaller, you get closer and closer, and you'll never actually hit your target. And I personally think this is one of the big problems with training any neural network. It generalizes too much. Like, your person's never exactly like the person you're training, or your concept's never exactly like the concept you're training. It's kind of an averaged out, lesser version of that. So with differential guidance, basically what we do is we take the difference between your current knowledge and your target, and we kind of do something basically like classifier-free guidance works. We subtract the differential, we amplify the differential, and we add it back. So now your new target is like way overshot. This isn't quite the same as just increasing the learning rate. Increasing the learning rate will get you from here to here. If you do a learning rate of 1, it'll actually hit here, but it'll explode the model because the model can't handle that. But it will never actually get you beyond this. It'll just get you closer to the target faster or destroy the model. With differential guidance, we're actually over amplifying the difference. And so it'll target just a little beyond the target, or maybe right at it. So when you do your step, you're now coming here, and your next step now is going to be back. It's going to overshoot a little here, here, and it'll work its way to the target. Just slightly different. It's just a little thing I came up with. It may not even function the way I think it does, but it does seem to work. I'm going to turn that on. I'm just going to do a guidance scale of 3. You don't have to do this if you don't want. It's experimental. I like it. I'm leaving it. We're going to come down. We have children's drawings selected. Everything can be the same. We're going to leave all the resolutions the same. So when we selected this model, turbo, it automatically set everything. So we have our sample step set to 8, our guidance scale set to 1. We don't need to mess with any of that. We're not going to touch any of this. So we're going to see what the model knows. We don't have to add trigger words because we're adapting it to, this is just how it is now. So it's going to hopefully start doing children's art pretty quickly on. I am going to bump this just so we can run it out if we need to. Sometimes these really amplified styles take a little longer. I don't have to come back in and restart it because I'm going to be busy packing and stuff while this is training. But that's it. Let's go back to the top. I want to go over how you can get this lower than what I'm doing today. First thing, if you have 24 gigs or more, set this to none. This won't quantize. It'll be way faster. You can set this to 8. Leave both these 8. You can also do cache text embeddings. I'll probably leave the cache text embeddings on because there's no reason to keep the text encoder loaded. This just caches all your text embeddings and then loads them up, unloads the text encoder. But this will save us some VRAM. I'm going to leave mine on none so it's faster. If you have 24 gigs VRAM, do this. You may be able to get by with less, but we'll see that in a second. Other than that, we left everything the same. We did turn on differential guidance To activate this, you just click this little advanced tab. Not needed, but I'm doing it. And other than that, we're all good. So let's go. Create that job. Okay, I'm going to go ahead and hit play. When you start this, it'll go ahead and download all the models. It's funny that I'm like, oh, this is only 14 gigabytes. That's real small. I remember back when you could do the entire text encoder and everything in under 2 with SD1. Now, if we're like, oh, it's less than 100 gigabytes. That's tiny. Things have changed in a few years. So you can see it's about 4 seconds an iteration. Now, for this one, the way I merge it in is I actually merge in the adapter LoRA. So you train without having to have the sidechain LoRA. And then when we're generating, we actually have a side chain of this. So we're actually slowing it down pretty substantially on generation. But you're getting like 4 seconds in iteration here on generating these images. It's so freaking fast. Absolutely incredible. Let's go look at the samples. Okay, so this is baseline knowledge. And you can just see here how amazing this little 6 billion parameter model is. Just look at this. I mean, it does photorealism really good. One of the things it does struggle with, though, is style and text. It's not the best at text, but it's pretty good. I mean, compared to SDXL or anything like that, it's light years ahead on text. But compared to like Flux 2, it's not as good at text. But if you like photorealism like I do, just look at these. I mean, they're incredible. Amazing detail, all that. Amazing. I stepped away for 1 second, and I didn't even get to go over the training speeds before it had the next samples. I mean, look at this thing. It's 1.27 seconds an iteration, 1 second iteration. We're averaging 1.3 over all resolutions. This model's tight and fast, even with the training adapter. It's so fast. And we come over here, look at our memory usage. 17 gigabytes of VRAM to train this thing, and we're not quantizing. I mean, we're training at BrainFloat 16, BFloat 16, 17 gigs of VRAM. So if you quantize this, you get that down even further. I mean, we're looking at 16 gig VRAM cards here we could probably run this on. If you get it running on something smaller, share it in the comments or hop on the Discord, share it in the config section. Let people know how you're training this on lower end hardware. I really want to know. But let's go check out the samples. So we're going from there to there. This is going to take a little bit, but it's starting to have a trajectory for sure. Doing a whole style like this, where we're basically changing the entire composition, it might be good to actually switch it to favor high noise, but I'm going to leave it where it is. It's getting there. We got to break up all of its knowledge because everything. You notice none of these look like cartoons starting out? Like even like the obscure ones like bears and dogs, it's still doing realism. Normally, these would be cartoons in every single model that you generate because they're not like a real picture. All right, we are at a little over 2,000 steps. I'm going to come take a look at samples here. Okay. So let's just go down the training run for this one, for instance. As we come down. Yes. Okay, that's absolutely awesome. Yep. I love the little child art style. I'm going to have a lot of fun with this one. Some of them don't have it. I mean, it's kind of doing it, but yeah, some of this is because we're not using a trigger word. I'll show you guys how to bump this and make it hit a little harder. But yeah, this one's looking good. This is the bear. Yeah, bear in the cabin. It's so good. I mean, some of them aren't doing it. Some of them are. It's about 50-50. Oh, I love it. Okay. Let's pause this. Make sure we're not saving or anything right now. I'm going to show you guys on this one. So even though it's style, we're technically wanting to adjust the content of the image, like the base layout, the very first high noise steps of what it starts to build. We don't want it to build a color image. We want it to start building a drawing. So one of the things you can do here, it's good to keep this balanced on time step bias. But for this one, we want to do the high noise. So those early time steps, we want to really, affect the image of changing all the composition, because this is a drastic change in composition we're trying to do. So this will do mostly the really high noise areas. So when you're generating the first few steps, it'll still hit all of them, but it just has a heavy high noise bias. Let's update that. Later we may go back to balance after we get everything moved over, because we still want to really focus on those little like textures of the crayon and all of that. That just depends on how it's looking. I'm going to start this back up. Remember, we are on step 2,250. All right, next step came in. All right. So you can see it was here and now we're here. So adjusting that to a high noise, it really helps rebuild the composition of the image. We're just focusing just on that. So, man, all of these, every single one of them, even the problem ones are all there. I just love that. I mean, look how much of a drastic impact it makes. So we go here, 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 here. Great. Okay, we are at 3,000 steps. Let's go ahead and give this a stop. That's the default number. I want to be done there. Let's go look. Okay, I'm going to go over to samples. All right, here we go. Let's take a look at these final ones. It's so bad, and that makes it so good. A woman with red hair playing chess in a park, a bomb going off in the background. It's just like simplified versions here. I love it. All the little chess pieces. Oh man, it's so good because it's so bad. I mean, that's the thing. We're teaching the model to be worse. Oh, it's a horse DJ. Look, he's holding a little record. Like all the little things it's doing. His martini glass. Oh, I love it. Okay. This is the man showing off his cool new t-shirt at the beach, a shark jumping out of the water in the background. I don't see the shark unless that's supposed to be it. There's one on his shirt. It's weird how the shirt's like a real shirt as opposed to a drawing. Like a mixed medium genius child. Okay, this is the bear building a log cabin. Great. Oh man, see, that one's intricate. This is one that you hang up on the wall when your kid draws it. A woman playing guitar on stage, singing a song, laser lights, punk rocker. Man, even like the little details on the strings. It's like the details there, but it's bad the way we want it to be. All right. Hipster man with a beard building a chair in a wood shop. God, love these. I just love these. This is a sign. Perfect. Oh. I just love this one, the progression. It comes down and gets worse, worse, worse. Okay, this is great. I love it so much. We're going to go ahead. We can load this up in the Comfy. That's supported now, day one. We had some issues with the weights, but Comfy jumped on it like he always does, and they got that done very quickly. I'm highly appreciative of the ComfyUI. We're going to download this, throw it in the Comfy. Let's see what we can do. Okay, we have everything loaded up into Comfy here. So this is all pretty much the default workflow currently. If you come here to templates, they have it right here. You may have to search for it depending on when you're looking at this. But Z-Image-Turbo text to image. We load that up. It's all in a subgraph. I just expanded it. I added my LoRa loader model only. We have our Z-Image-Turbo LoRa loaded up. I actually prefer this at 8. That's what they mention on the page. We can leave the rest of this the same. I think res multi-step makes it where 4 works. I'm going to switch it over to just Euler for now. This is really big. You can probably do it that big. We just didn't train it that big. We won't do all this. Wide angle view of a dog flying a plane in the pilot seat. Let's give it a run. Perfect. I mean, everyone tries to make things that are like way better art than people can make, but I just love this little kid style. Like, it's not too much like a plane. It's like a kid would draw a plane. All right, let's try something else. A skateboarder doing a kickflip down a flight of stairs. Oh, I just love this. Look at that. Oh, it's so good. I mean, these are actually like kid drawings. It's so, I don't know. I just get warmed up. I'll do something kind of racy here. A woman at a strip club. There you guys go. I mean, screenshot that, save it for later. Don't say that I don't go racy with my content. That gets you everything you need right there. Look at that. It's beautiful. Let's go ahead and give it another run. Men, contain yourself. Okay, let's see what else we could do here. We have Christmas coming up, so let's do this. Santa holding a bag of Tongyi. Okay, yeah, that mistyped it, but there we go. Santa holding a bag of toys. He is flying over the city. And finally, we have to do one final one. A horse holding a sign that says, I trained this Z-Image-Turbo LoRA on AI Toolkit. And there it is. I just absolutely love this style. All right, guys, that's it. That's how you do it. That's how you train Z-Image-Turbo LoRA. If you're trying to train a character, it works basically the same way. Don't switch to the high noise option of doing a character, though. You can just do it balanced. You can do time steps of weighted, sigmoid. All that will be the same. Character LoRAs actually train a lot faster. I may cover that in a video too. But this model is not great at style. It's focused on realism. So we took it to the extreme anti-realism here. So this is just to show you, you can go this far with it. So everything else along the way, you can easily do. If you found this helpful, do what the bear says. Be sure to like and subscribe. Click those buttons at the bottom. That helps me out a ton on YouTube. And shameless plug time. If you enjoy this video, you enjoy AI Toolkit, you enjoy my work, figuring out how to train a turbo model and doing all that, I don't make any money from using my software. If you're using it on some service, I don't make money from that. All of my money is made from supporters. That's it. That's how I make my money. So head over here to ostrus.com/support. You can support me on Patreon, GitHub sponsors, PayPal. You can buy some merch, get a t-shirt. You can check out all of the amazing supporters that make all my work possible. Many of these people have been supporting me since day one. Like the very first time I was like begging for money, these people came in, and a lot more people have joined them along the way. And that's what allows me to do this full time. I'm finally about at the point where I'm about making ends meet and not blowing through my savings like it's on fire. Thank all of you so much for donating, and please consider supporting me if you find this helpful. That's it. I hate begging for money, but I got to do it. Go make some really cool Z-Image LoRAs. I love you guys. I'll see you next time. Bye.